What we want to talk about is the 175 codes that we've been getting on these products. And in some cases where we've been changing out the sensors and still getting the codes. So it's a little confusing to us. And then we're going to touch on the J2 jumper on the XR products, to when we should or when we should not cut them. That's a good, we want to make sure we do it right. We always want to do our stuff right. So after that, I'll give it to Aaron and let him do his thing.
All right. So we'll start with the 175 code. The 175 code is what we call limp mode. Basically, this is a safe operational characteristic for the heat pump. It's 2,400 RPMs, so typically this is going to be part load capacity. The 175 will always be associated with another code, whether it's a 16501 for low superheat, a 165 for high superheat, or one of the 67 error codes, something like that. It will always have an associated code. And it may not be on the 950 or the 850 in the alert history. So a lot of times we need to go into the alerts and the alert history in the outdoor unit CDA to see all of this information. All right, and so that's where we're going to start. I've had two calls today where they were both 175 limp mode with 16501 error codes, which is limp mode caused by low superheat. When we started diving into them, one of them was a suction line temp sensor was not seated properly on the pipe, and so it wasn't reading correctly, and thereby giving us the low superheat because it could never read correctly. I had another one. The other one was just a bad suction line pressure transducer. It was reading about 10 pounds off, which is roughly about 8.5 or 9 degrees, and that's why it couldn't read correctly as well. So those are the things that we're looking for to start mapping out why are we getting this issue. I've also had some low superheat in the cooling mode during the Christmas season, usually right after Christmas or right after New Year's, in which they had low superheat in the cooling mode. Well, the only way you can get low superheat in the cooling mode is to have the unit physically go into cooling operation. Well, if it's 10, 20 degrees outside and we're running cooling mode, yeah, we're going to have low superheat condition. And so that would actually be what we'd consider an expected alert. We just need to let the homeowner know that if you got to run cooling mode and it's 20 degrees outside, maybe you ought to look at opening up a window or a door or something, allow some fresh, cool air into the house. So variable speed units aren't really built to run below 55 degrees right now. The factory's looking at that, but that's really not how they're meant to run in cooling mode below 55. So just bear that in mind. So when we're dealing with 175, first thing we need to look at is what's the associated code that caused the 175. Is it an error, a sensor that's missing, or is it a superheat condition, or something else that's causing that? And that's where we need to start. All right?
So you're saying it's not always the sensor?
It's not always the sensor. It could be a condition that's causing the system to act this way, like I said, in the cooling mode at 20 degrees outside.
Okay. So on these dome sensors we talked a little bit, which we were getting kind of a related code, how often are you actually seeing dome sensors fail?
Realistically, not very often. Usually when a dome sensor, most of my sensor errors that I'm finding are a connection issue that they just happen to fix when they replace the sensor, or it's a issue within the system that's causing the superheat to come up, or the dome temp sensor, or for the dome temp to create an error code. Like a higher than expected superheat will raise dome temps. Okay, so one of the most common ones I deal with on the dome temp sensors is 18507. I get that on my house every 3 months, roughly. And what that is that's high dome temp when we're running at low speed operation. Guaranteed that one is an airflow issue. My filter needs to be changed when I get to 18507. So we do see a lot of those dome temp sensor error codes, or error codes related to the dome temp sensor, just from the pure and simple fact of coils being dirty, or overcharge in the system, or a superheat condition of some sort. I had one that the homeowner had a wood stove. They were running the main portion of the house up to 80, 85 degrees, and then the system would kick on because the stat was in the back room, and now we're taking most of the return air out of that main room where it was 80, 85 degrees, and it's trying to run the heat pump, and we're over temping. Those are the types of things we're looking at.
Okay, that's good information. So, yeah, because I think we were kind of jumping on the category that the sensors were bad, which now tells us to go look a little bit farther. Did anybody else have a question on sensors before I change the subject on him? Travis?
Getting a lot of limp mode, I've noticed. What causes that to show up quite often?
That's what we were talking about before you were able to jump on, Travis. Limp mode is always associated with another code. And whether it's a low superheat, high superheat, a sensor out of range error, something like that will create a 175. So there's always an associated code that we really need to look at, and that associated code may not be displayed in the 950 alert or alert history. You may have to go out and look in the CDA alerts, because there's some alerts that are not displayed at the 950 that are in the outdoor unit.
Okay. Cool.
Matt or Victor, did you guys have anything on that?
No,
No.
pretty much covered it.
Okay. How about you, Victor? Any questions on that before we move on?
No, I'm good on that one.
All right. So another quick question for you, Aaron, and because we are running into this a lot, is noise complaints on the XL20, not so much on the XV18, but the 20. So what we've noticed we've been doing, and this is our steps, you can tell us if we're wrong or right, is that we've been, one, throwing it into high defrost, make sure the unit's in the high defrost, and then we're lowering the maximum RPMs on the outdoor unit in the heating mode down one step. And we're making sure the charge is right.
Okay. So, Ken, I'm going to forward you something here real quick.
Okay. I did get that letter from you guys where it said expect it to be noisier.
Oh, okay. Yeah, I sent that to you so you could send it out to the guys. So, as far as compressor noise, remember, guys, when the variable speed unit drops below 10 degrees, our maximum RPM is nearly double that of cooling RPM. So cooling RPM, max RPM in cooling mode is somewhere typically between about 3,300 and 3,600 RPM for a compressor. When we go into heating mode, we will ramp this compressor up to the point that we're running nearly 6,000 RPMs. All right, so we're really cranking this thing up. In all units built from 2016 and on, we have a new noise blanket. And this noise blanket is 4 layers of insulation of a kind of a polymer type insulation, almost like a rubber type insulation. And this thing weighs about 16 pounds. It's also new compressor feet, and it's also a pan that slips under the compressor, that the metal is a sound absorbing metal. It's actually kind of cool. If you take the 2 pieces of metal, slap them together, instead of going ting, they go thunk. Okay? So on units built prior to 2016, the serial number starts out prior to 1/6. If we don't have the new blanket on there, you guys can warranty out a new blanket and put that on there. Okay? That's a new sound enclosure kit. Takes about 30 to 45 minutes to put on. The other thing you're going to look for is noise, typical noise creation. So we're going to look at tubing rubs on the line where it drops under the coil. If you lift up on the reversing valve and the noise level changes, that discharge line's rubbing on the bottom of that pan, that plastic base that the unit is built from, and it creates almost a speaker effect. And then it bounces between there and the pad, and it'll just emanate that noise everywhere. Okay. Another place I've had it is on the inside where you've got that big loop for the muffler, where there one line turns to go under, another line turns, and they intersect. And I've had those sit there and bounce together, and it creates a heck of a thudding noise. Okay. I've also seen where one of the distribution lines for the EEV is up against the fins on the door for the unit, creating noise as well. So we're going to look for those tubing rub areas, those type of noise areas, to fix excessive noise that way. One of the first units I dealt with on a noise issue, Travis and I were out on a unit that was installed under a deck, and we pulled about 8 ounces out of this unit, and it dramatically changed the noise level. So do make sure that you're charged and charged accurately. If everything there is good, then chances are the noise level is proper. And that's one thing we really need to have the salesman doing, is prepping the homeowner. Hey, this unit's going to sound differently, and when it's really cold out, it's going to be much louder than you normally expect. Okay? And by explaining what's going on, that we're ramping that compressor up so that we can use the auxiliary heat less, most people are going to be okay with that. If they're not okay with it, then yeah, our last step is going to be to go ahead and reduce that maximum RPM in the heating mode from factory to medium or to low. That's our 3 options. Factory is the highest speed that the unit can achieve, which is usually about 6,000 RPMs. Medium is going, let's go to low. Low is basically going to be cooling RPM. Okay, so cooling RPM, if let's say a 3-ton unit is just shy of 3,600 RPM. It's actually 3,592. Okay, so let's just call it 3,600 RPM. You got 6,000 on the high end. 3,600 is your low. Medium is basically halfway between those 2 numbers. Okay.
Are we dropping capacity with that too?
Absolutely.
Okay.
So if we're not running that RPM, we're only running it up to say 4,800 on medium, and we're not going up to that 6,000. Yes, we are dropping BTU capacity of that outdoor unit in the heating mode, which means our auxiliary heat's going to have to come on more. But you know, some people are okay with that. They would rather have the auxiliary heat come on a little more, pay a little more money and energy, than to have their than to have that noise out at their outdoor unit. Placement's also a big issue. I know one of the units we went out on a number of years ago, it was installed kind of in an alcove off the master bedroom, in which there was a roof right above us, and there was concrete behind the unit to the right of the unit, and that noise just bounced around in this alcove and just gained in sound every time it bounced. Moved that unit around the corner, and the homeowner was happy. But those are the things that we run into. So we do want to watch placement. I had another one that was installed in between two houses that were only about 6 or 8 feet apart, and the noise basically bounced between the two houses, and would, every time the noise bounces, it would gain a little bit of volume, if you will. Standing next to the unit, it sounded great. You stood back 15, 20 feet, and you could really hear that. And that's a harmonic sound that we were hearing because it was bouncing in between the buildings. So those are the things that we've got to watch out for. Sometimes you can't avoid it, and that's just the reality of it. We can't have the perfect scenario out in the field every time. So do the best with what we've got on those issues.
So before we get too far, go into that next thing is the jumper. We're seeing a lot of vibration in that 3/8 line set in the unit. That's part of just being an XP product, right?
All variable speed product is going to have a little more vibration on the liquid line because the liquid line is actually carrying a dense material, right? We're liquid. We're more dense than gas. That's why you see it in the liquid line and not in the discharge line. And the other thing you have with the variable speed unit is because that compressor is ramping over different frequencies, we're going to be more likely to hit harmonic points in the system. Okay? And so that's some of what we deal with as well.
Okay. Well, that's good to know. Yeah, me and Travis noticed it on one that we actually had to run a new line set. You were out there too. We ended up pulling a new line set on it.
Yeah, well, and that one very specifically, that was part of an install-related issue in which we would have never have thought about it under a normal situation where we just the line set was ran up the wall right behind a shower. But this shower was, what was it, 6 foot by 4 foot or 6 foot by 6 foot, something like that.
Yeah, it was huge.
It was a tile wall, and the shower was surrounded in glass. And so the vibration of the line set was being transferred into the tile, creating the vibration through the window on the other side that was carrying into the rest of the house. That was an unusual situation, but because the line set was strapped tight to the stud, it allowed that vibration to transfer in.
Okay. All right, so last thing we want to hit on is that J2 jumper on the XR15. And I want to make sure everybody's on their understanding because we just started talking about it this week and that we're doing it right if we're going to cut it.
Okay. On defrost control boards, all of our equipment since about 2010, and you can look in the service facts of the unit to see for sure. If you're not for sure, give me a call with the board number, and I can also help you through that. But since about 2009, I think is actually when we started implementing it. We added a J2 jumper on the defrost control boards. And that was very specific for our region. Bobley and Eddy had gotten that pushed through, in which it raises the defrost termination temp from 47 degrees to 70 degrees. What this does is every once in a while when we have those long bouts of that heavy, dense, freezing fog in the area, the units won't completely defrost. And we'll get this banding on the coil. So you'll have a section of ice and then a section of clean coil, a section of ice, section of clean coil, all the way up, and it'll be heavier on the bottom and slowly dissipate in ice buildup at the very top. And so you'll have heavy ice and then section of clean coil, a little bit less heavy ice, section of clean coil, and it'll get so bad that it's pushing out of the unit. So what we did is we created this J2 jumper to deal with that freezing fog issue. So if you're running into a unit that has that banding happening, cut the J2 jumper that raises the defrost termination temp to 70 degrees. Here's the downside. Defrost is a very, very inefficient process for a heat pump. It robs our system because we're running cooling mode and we're running auxiliary heat. So it's a very inefficient process. So we want to minimize that time. All right. But if we can't get fully defrosted, we're going to have to give up that 47 degree defrost. Now that only happens, that 70 degree termination temp only happens below 30 degrees if you cut that J2 jumper. Okay, so once we get above 30 degrees, we're back to that 47 degree defrost termination temp, even though the J2 jumper is cut. Okay, so we're going to look for banding. If we're getting banding during the freezing fog temperatures and the homeowner is dissatisfied with it, or if it's pushing outside of the unit, cut the J2 jumper, and that'll take care of the issue. On the variable speed outdoor units, every unit you guys install, you need to be putting the defrost termination temp on medium. And if you are having defrost issues, then take it to high.
Okay. I've been taking everything to high, so I'll change that to medium.
Okay, if you're taking everything to high and everything's going good, I'm okay with that.
Yeah,
That puts your defrost termination temp at about 60, I believe it's 64 degrees.
Yeah, because first one that I updated was Terry Bonetta's house, and I put it on medium, and it's still on medium today. And he showed me some pictures of banding going on it.
All right, perfect. Then let's go to high on all of them.
Yeah.
Make sure that the installers are doing that as a standard practice.
Well, I'd like to say that we just started that a couple weeks ago.
Yeah.
So
Well,
we're gonna set it on high or medium?
I'm gonna go with high.
High.
High. Is that gonna kick more often? And the frost, is that gonna be like more often, like every 20 minutes or every hour or what?
What that's going to do is it's going to keep it in defrost longer. Ideal defrost is about 4 minutes is what the factory shoots for. In our case, with the freezing fog, we're going to extend that out because we're going to go to a higher defrost termination temp. So it's probably going to keep us into defrost somewhere between 6 and 8 minutes.
Okay.
And you could actually see on the CTU or the display what temperature your coil's at in defrost. I noticed that on mine.
Yes, on the variable speed, yes. Now, on our new defrost boards, instead of a J2 jumper, it's labeled JP2. And it's down towards the bottom of the board.
Is it still a cut or is it a jumper?
What's that?
Is it still a cut or is it now you got pins to go over?
It's a cut. It's
Okay.
a physical cut on the board.
Okay. All right. Anybody got any questions? All right. Well, Aaron, thank you. One quick thing is when you guys are safety topic, when you're walking around the house, keep your head up because I ran into the side of the house, got the side of my head. That was me and Raul were working, and I about knocked me out. So keep your head up when you're walking. I was walking with my head down and just turned right into the wall. I thought it'd be a funny video, but no. But yeah, you want to see it, Victor? Right there, man. Right on the side of my head. Right in the bald spot where I can't hide it either. So, all right, guys. Hey, thanks for joining the meeting. Work safe. I hope we got some good information. Aaron, this really helped. It's stuff that I can't even share. I remember I think Aaron's gone.
No, I'm here.
Oh, there you are. So thank you. Quick, easy. You didn't have to drive to Tri-Cities and tell these guys something that we can learn this fast. So, all right.
All right, great. Glad I could help.
Thanks, Aaron.
Thank you.
Guys. Talk to you later.
All right, have a good one, guys.
Bye-bye.